Welcome to the Friends of the Earth Ireland System Change webinar series. This aims to facilitate learners to connect the dots between global justice issues, to draw out the root causes of injustice and reflect on action pathways, while also amplifying the work being done by groups locally and around the world. Today, we're furthering our knowledge of economic justice with Paul Goldrick-Kelly in order to empower learners and activists regarding this topic. Paul is an economist at the Nevin Economic Research Institute based in Dublin. As a graduate of UCD with a HDiP and MA in Economic Science, Paul's work has looked at issues related to many of the system change topics that we've looked at in this series, including healthcare, housing, tax and revenue sufficiency, and productivity performance in the Republic of Ireland. Paul's research relates to ecological sustainability and political economy related to just transition. Paul is currently engaged in a collaborative doctoral research project with NUI Maynooth concerning carbon lock-in. So I'm so glad that we have Paul here today, and I'll pass over to you now, Paul.
Thank you for that introduction, Evelyn. I'll start sharing the slides now. Sorry, can everyone see that? Great stuff. Okay, I'll put that in slide mode here. Okay, yeah, as Evelyn said, this is, I suppose, my recent work is tied into a program, a PhD, looking at carbon lock-in in Ireland. The idea being that there might be certain sort of systems in place that impede climate action, even though all of us sort of know that we need change. But I'm just going to go through a few topics. I sort of, as I kind of thought about this sort of presentation, I thought of what might be useful or interesting, or what might I bring to the table that other speakers might not have. So I do have charts and some data, unfortunately, so hopefully I don't lose you, but perhaps, you know, in the question and answer, I'll try and leave some time for that. We can kind of get through like what they mean, what are the relevance of those statistics. So in general, I'm going to just divide it in three. So there's how is Ireland doing on the emissions front, which it seems, you know, straightforward enough, but it can actually be a bit of a complicated question, depending on how you measure it, really. What is the relationship between emissions and employment? That's kind of really where I'm linking it back into that just transition theme. I know you've received a kind of a presentation on that topic, but just to go through some data there. And then to sort of revert back to the bigger picture, some kind of bigger policy issues, debates that I just sort of touch on, but perhaps that'll come out in the discussion as well. Okay, so how is Ireland doing on the emissions first? So first things first, what emissions are we measuring? And as I point out here, you actually have several different methodologies. The one that you'll hear from the EPA, the one that you generally hear when you hear something like Irish emissions went down 6% in 2020, that's territorial emissions. So those are emissions tied to activity that occurred on the island or in the territory of Ireland, right? And that's usually what our targets are based on. That's what the climate action plan is based on. That's what the EU kind of mandates are based on. But you have other conceptions which depend on sort of different forms of measurement and different kind of purposes. You also have something called resident-based emissions. So that's business units or residents attributed to Ireland, what emissions are associated with them. And then you have the latter sort of numbers 3 and 4 here, consumption and income. And those are in a lot of more kind of critical literature. And these actually remain fairly underdeveloped, but they're sort of advocated for because in many cases, for example, you can have apparent improvements, say, in terms of emissions that occur within a territory, the UK being a classic example, but that might just simply be associated with deindustrialization. Those dirty processes no longer occur in the UK, they occur somewhere else, but the consumption of UK residents is still sort of generating those emissions. And the last is sort of related to that, but it's more about who gains income through the supply chain. So it's where income from these processes are generally sort of if you're aware of, you know, the classic examples of the production of coffee, say in the global south, you'll have an extractive industry which will produce very little value added, whereas most of the value added will be capturing the global north. Now, if one was to measure the emissions associated with that, you'd go to where the money goes, essentially, that approach. And that would probably be the least developed of the four. I know we don't really have statistics like that for Ireland, but depending on what sort of thing you want to measure, what kind of conception of the problem you kind of want to think through, each of these might be relevant, okay? So as I said, though our targets are based on the first, but the others might also be relevant in terms of Ireland's impact in the world, what we might be responsible for. Okay, so going to the first two, because these are the two for which we have readily available data. You get similar trends here. Now, all of these are in 1,000 tons of CO2 equivalent. You might kind of be familiar with this, but essentially it means, for instance, methane holds more heat than carbon dioxide, about 25 times more heat. You can convert methane into a common carbon dioxide equivalent unit. So you can put all greenhouse gases together at a common scale. And you can see here up until about 2013, now actually this was really the result of suddenly our statistical agencies adding the impact of airlines into our emissions. But if you look at those territorial emissions, we look okay, although most of the decline came during the recessionary period. We had a bit of an increase as we recovered, and then some declines over the last few years, and you have of course a COVID-related decline, but you see a much larger series, and with a significant gap. For example, if you look in 2018, we're talking about 80 million tons of carbon dioxide equivalent versus 60. That's if we attribute it based on who's an Irish registered unit, and primarily, as I said, that's certain airlines that you may know the name of. Okay, so what's going on with that gap? As I said, here's 2019. So that's I take 2019 because 2020 is a bit of an unusual case given kind of what happened with COVID and lockdowns, etc. So you have here, you add in emissions associated with fuel purchased abroad. So it's pretty modest for road transport. It's enormous for air transport, about 17.5 million tons of carbon dioxide equivalent. Then you subtract emissions purchased by non-resident units on the island, you get a nice big figure, but a substantial disparity between top and bottom. But the top will be what you kind of see in EPA data and government targets. The bottom is what's attached really to economic activity. And that's sort of the purpose of resident emissions. And as I said there, you get very different data. Now, I was kind of loath in a certain way to include the consumption-based indicator because there's a lot of work. As you might know, there's a kind of controversy when we're dealing with the agricultural sector where we say, right, if we're talking about a consumption-based measure, should we attribute those agricultural methane emissions to Ireland or to the end destination of those goods? But some kind of, some databases put in kind of rough estimates, but in any case, the message here really is consumption-based emissions will be a bit higher than the territorial-based ones, and resident ones will be significantly larger. So these are emissions per head, so that's approaching 16 tons if you measure on a resident basis, and about 12.5 on consumption-based, and just over 12 for territorial. Now, as I say, the different forms of measurement might also raise questions about the unusual features of the Irish economy, how we're structured, those sort of international flows. They're not directly tied now to, kind of the famous kind of leprechaun economics, but it raises a question. When you look at our data, we actually have far larger disparities between these territorial-based measures and the resident-based ones. So it's indicating something peculiar might be going on, and it might be worth investigating. So going on to what is the relationship between emissions and employment, which I think really kind of might be a key issue if we're looking at this from more of a just transition perspective. So one way economists like to divide what's happening in an economy, we say it's a NACE classification. So it's dividing the economy into sectors based on what you primarily do. There's 21 main ones. You can do various kind of subdivides within those sectors, but I won't go through the full lot. But in any case, you can measure economic output, employment, and emissions. Now, one complication, of course, I've already referred to it on the economic output side, of course, is the famous leprechaun economics. It's hard to sort of get a real sense of activity happening within Ireland, given the fact that many of our statistics are a function of huge multinationals onshoring intellectual property on the island. So I'll just stick to employment and emissions. And indeed, as I referred to, this is the main purpose of resident-based accounting. This is resident-based emissions accounting, as opposed to emissions inventories, but those are the ones you'll see from the EPA. These emissions were designed to attribute emissions to economic activity. So that's to provide a match with national accounts. You can also sort of do adjustments if you subtract from certain sectors. So here, the exercise here really is both to demonstrate where emissions are concentrated versus employment, and also to point to kind of what sectors have very high emissions intensity jobs. So we can see there the biggest culprit, at least in these data, is electricity, gas, steam, and air conditioning supply. Primarily, that'll be about electricity generation. About 13.3% of emissions based on residents. You have about 13,700 people employed in the sector. That's 13.3% of emissions, 0.6% of employment. Okay, and you have emissions per job of about 600 odd tons. The next sector surprises no one. That'll be agriculture, over 20 million tons of carbon dioxide equivalent, more than a third of NACE emissions, 100,000 people employed. So it's about 4.5% of overall employment, but a third of emissions. And that's about 200 tons per job. And now the next sector is really where the divide between whether you're measuring those airlines in terms of Ireland's footprint or not. If you measure them on the Irish books, transport looks like a major sector in need of reform. So as we can see there, it's just shy of 200 tons per person. Again, another third really of emissions, and about 4.6% of employment. And again, we kind of continue down. So in general, you can kind of see these few sectors, although manufacturing even kind of less so, they have emissions profiles far in excess of what's sort of typical for the economy. It's usually 27 tons per job. What's typical. But if you do the same exercise, now, like, the usefulness of this exercise is really to see if can I link those kind of employment numbers, those emissions per sector, to what the likes of the EPA report and what our targets are based on. And so if we do that and you adjust those transport numbers down, you know, for those airlines, you say, well, they're not occurring within the territory. Again, you get the same kind of main culprits here. Now, this is from a table where I'd actually included as an appendix. These are codes. But in essence, again, that's the electricity generation. There's agriculture, water supply, transport, manufacturing, and other sectors, essentially. And what's sort of significant here, you get a similar story. There are certain sectors with not that much employment, but highly concentrated sort of emissions. And this also gives you a sense of where progress in terms of our emissions have come from. The one sector that explains really all of our progress between 2008 and 2019 is electricity generation. So we do have a situation where electricity generation is generating most of our gains, but it is the most emissions intensive sector. Okay, so we also get to, again, another just transition element now to explain this table a little bit. Along the bottom there, you're looking at, so these respectively, these border west, midwest, southeast, southwest, etc. Dublin, Mid-East, and Midlands. The figure at the bottom indicates that about 8% of people employed in the state are employed within that border region. So where you see a number basically above 7.9, that indicates that this sector is unusually concentrated there. So we can see in this chart, we see 18.2 next to the border, for example. Nearly a fifth of all people employed in agriculture live in the border region, but only about 8% of overall employment is in the border region. So that tells you this is a place where an unusual concentration of agricultural jobs are. Now, the significance of this really is we have emissions intensive sectors, and they constitute a minority of overall employment, but the majority of overall emissions, but they're also concentrated in certain parts of the country. And the concerning element of that, as we know from, say, reported pneumonia cases, etc., that we've been kind of dealing with is those also tend to be places in the country that are relatively less well off in terms of incomes compared to Dublin or the southeast, where Cork or something like that. Okay, so this exercise again, I hope this isn't a sort of barrage of data, but just to demonstrate a point, I went with two scenarios. What if Ireland's emissions per job looked the same, but we had the kind of employment shares, so the number of people that a Belgium, a Denmark, or a Germany have within the sector. So we know, for example, that agriculture is unusually large in Ireland. So for instance, if we have 4.5% of people working in Ireland within agriculture, if we assume that nothing else changed about agriculture except the amount of people working in it, so say in Sweden, if it's about 2%, you'd adjust emissions accordingly, multiply by half the employment number. And this looks at these changes, and you can see they're significant. So what that's telling you is that a big part of the emissions story in Ireland is the composition of our workforce. The basic structure of our economy is explaining a good bit of the emissions that are registered in the state. And sometimes it's very significant. As you can see there, the little blue bar indicates 2008. So we can see actually in relative terms, because the green bars are more negative, we've disimproved relative to the European average. Okay, that shows that we're sort of not progressing in relative terms, even if I suppose that would indicate that their emissions are going down faster than ours. The other one on the right, that's if you changed everything else the same, our labour market looked the exact same, 4.5% of people still have worked in agriculture, but we changed those emissions intensities per job to comparators. Now you can see the likes of Belgium don't look so great anymore. They'd actually add emissions, but you'd have significant changes if we resembled somewhere like Sweden. We might lose about 20 million tons of carbon dioxide equivalent. Okay. So takeaways from that, why do any of those stats matter? Whichever of those employment or emissions indicators rather we choose, you get a similar kind of message. Emissions are disproportionately concentrated in certain sectors. They're significant, they're not nothing, they're comparatively large compared to other countries, but they're still relatively small. So about 90% of emissions are attached to about a fifth of employment. And actually, if you divvy down into subsectors within those, you can actually kind of reduce that less, right? The major high intensity sector showing progress at all really is emissions in electricity, gas, steam, air conditioning supply. And just to even take you back to that chart, emissions change, you can see agriculture is also going in the wrong direction. It's added a million extra tons of carbon dioxide equivalent, which is obviously concerning. So you can make a decent case. Now, obviously within an economy, all these jobs are linked. You can't just say, well, like whip out that job and nothing else will be affected. But there's a decent case to be made that if you're identifying jobs that are unusually carbon intensive, they will probably be the kind of jobs that will be immediately affected by any transition efforts, right? And we also have that fact that I showed you. Employment within certain regions of the country are disproportionately concentrated in those sectors. So there's a kind of spatial element to this. If we're transitioning, some areas are going to transition likely more than others. And some structural features of the Irish economy help explain our emissions. So where people are employed, the kind of sectors Irish people work in, has an implication for what's registered on our books. Should we be worried? Yes. Unfortunately. So the attributes of many people in these sectors, and in turn kind of that worked with me, actually investigated what you'd call risk factors for transition. So there's big employment literature that says what kind of people find it difficult to find a new job should they lose their current one. And a lot of the features that you typically associate with people who have difficulty finding new jobs are shown by people working in sectors like agriculture. And as I pointed to in this kind of classic transition story, we know of even from other regions of the world, high emissions jobs are concentrated in relatively low income areas of the country. Okay. More broadly, and these might be kind of data you may or may not be familiar with, We also show, like in terms of or matching of skills to jobs, which might have implications for how things kind of shake out where people work. Ireland shows high skills mismatch rates. So you have two forms of that. You can have people who are sort of overqualified for their current job, or you can have people who specialized in some field and are currently working a job that is in no way related to that specialization. In both of those categories, we're unusually mismatched. Okay. Now, why should one care? In general, a lot of the economics literature says you suffer a wage penalty, you suffer satisfaction penalties, and in practical terms, you're not deploying skills where you might need them, which might be relevant given the need for a relatively quick change here. So if you match things better, you might aid your transition effort and make people more satisfied and better paid to boot. And so other research implies that on-the-job training might be significant in switches. So there's a big literature that says a lot of people actually won't experience, say, wholesale job loss, but what they do in their current job will change because of new regulations, new ways of doing things. And the primary kind of thing you'll need to do isn't to sort of change the degrees everyone has, but it's to give them additional on-job training to adapt to that new situation. Given that fact, though, if you look at what percentage of people in various European countries receive on-job training, Ireland is near the bottom alongside the UK. We get very low rates of in-job training compared to other countries, which again, that's a sort of a bit of a flashing red warning in terms of transition efforts. So how does this link to the bigger picture? I spoke a little bit about kind of employment, because I think that's really where the rubber hits the road here. But I guess this presentation is sort of the Irish economy, or the economy's relationship to the environment. So getting to that space. You may be familiar with this term, may or may not be, but this is where we get into, many of you may be familiar with, kind of the debate around degrowth, things like that. So essentially, most plans, when you kind of talk to economists, our dominant kind of way of thinking is, well, we'll continue to grow because that's what incomes are based on, that's sort of our collective prosperity. But to do that, our impact on the wider world, on the global ecosystem has to go down. So in some way, that historic linkage, they used to environmental damage and emissions and energy use, all those kind of things. Historically, they've gone up in tandem with the economy expanding. Decoupling means that that link is severed, that economic growth can continue, but resource use, pollution, pollutants, emissions can go down, right? But there's, as I say there, that implies your environmental bads decrease for every unit of economic activity. And that's your emissions decoupling. Now, you can have two types of it. You could have a relative rate, which means that the amount of emissions doesn't go up as quickly as economic growth. If emissions increase by 2%, and the economy increased by 6%, you could actually say the economy is decoupling. But obviously, given kind of what we know, IPCC reports, that won't be good enough. That relative improvement in efficiency isn't sufficient to avoid climate catastrophe. But you'll need what's called absolute decoupling, which means that the aggregate amount of environmental bads we're producing is going down while growth goes up. That is, if you're attached to growth. So logically, if we're to sort of reduce our impact on the planet while continuing to grow, absolute decoupling will have to occur. Next question would be, has that happened? Again, this is where, how are you measuring emissions is relevant. Now, kind of concerningly, a lot of until maybe the last couple of years, you'd say no. Where our Irish emissions declined, it was because essentially we had a recession and people stopped going to work and the economy contracted. Now, if you look at the territorial emissions line, that's the line that's flatter there. The two dashed lines represent the economy. It depends on how you measure the economy, but the little green line is kind of considered the most accurate one that strips out all that multinational stuff. The territorial emissions are showing some signs of absolute decoupling, but if it has been occurring, it's only very, very recently. The resident-based one, it's far more ambiguous. Perhaps a single year, and then not very much. So this kind of even just presents you a little mathematical problem, okay? We have to have absolute decoupling, but if we have to reduce emissions at a certain clip, this gives us, you know, a certain kind of idea of how much decoupling has to happen. Right? So I just, a little toy model here, considering the following. The current climate action plan, on average, implies about 7% fall in reductions, or fall in emissions rather, per year, every year on average, until 2030. Economists typically say that an economy is going along healthily if it's growing by about 3% a year. If you have an economy growing at 3% a year over a decade, the economy is going to be at about a third larger by 2030. This tells you, this gives you a little, if those two facts are true, to be true at the same time, the amount of emissions per euro is going to have to fall by about 10% a year, which is huge really in terms of its technological implications. So that's just, for those two things to be true, you have to have emissions efficiency gains by 10% a year. And this is also just even kind of turning to other ecological problems other than the climate. I did a little bit of work last year based on the kind of planetary boundaries framework, where they had some key indicators, key systems that humanity has to abide to keep an ecologically stable kind of environment that sort of, they called it safe operating space for humanity. You might be familiar with this if you know kind of Kate Rayworth, the donut economics kind of stuff. And if you apply some of those limits to Ireland and you say, right, these global systems, if you say that, yeah, we have equal sort of kind of right to those sorts of global systems, that we're entitled to an equal share of that kind of earth carrying capacity. You see these charts here. In terms of CO2 emissions, we're about between 17 and 18 times above what ought to be kind of carrying capacity. We're above kind of sustainability really in 6 of the 7 boundaries, except freshwater use. So again, that's a cause for concern. And just to sort of go to that main conceptual point, and we might get to this in the discussion because it's a big issue. If you're curious, we can leave it if you're not interested. But given those kind of absolute boundaries, and if we look at that kind of little model and we say, right, actually to respect these boundaries, and if the economy is to grow, that implies huge sort of gains in efficiency, huge gain in what we can extract per unit of resource. That implies, given that kind of unequal distribution, and the fact actually that we know that this probably gets into more of a normative kind of values-based element, but if there's people, you know, in the global south who actually don't have access to enough resources, it might be the case that finite global pool has to be kind of distributed a different way, and perhaps the global north, well, actually, I suppose in absolute term, the global north has to sort of reduce its kind of environmental footprint. And to really achieve that, if it is to be that growth isn't consistent with that kind of respecting those kind of environmental boundaries in a socially just way, that could imply a really fundamental transformation in our institutions and even, you know, kind of policy making. But just to, I suppose, to get to, in some senses, regardless of your stance on that debate, the immediate kind of policy kind of menu open to most people who might, you know, kind of have something of a progressive outlook in terms of what sort of government and society ought to do. In general, you'll come to similar enough conclusions, but here, you know, just kind of referring to where we are right now. So at minimum, given those structural features I showed you, the pace of change that we need to achieve, even just to meet our legally binding targets, the question of whether those are adequate is another story. But regardless, that implies a significant kind of course change in the direction of the economy. What I outlined to you before implies really that policy should be trying to sort of shift that. We need to really change some of those structural features if we're to have the kind of job transition we require. And given what we know about the regional concentration of these jobs and the fact that these regions of the country are often underserved already, to satisfy really kind of a just transition of any sort, you'd have to step in to ensure that this kind of transition isn't just going to exacerbate those kind of regional divides or make these worse places to live. You'll need significant new infrastructural investments, and it's hard to see this occurring without state involvement, the state taking the lead on it. Now, to give some credit, there have been kind of step ups in ambition. The likes of the European Green Deal is, I mean, even apparently large figure there that points to something would change. You can question, is it enough? Various researchers have pointed out that even that trillion euro figure is still only about a third of the estimated green investment gap. And the large figures that you kind of see in the likes of the EU's investment plans, the Irish government plans, they're primarily drawn from private sources. So again, kind of referring to my previous point, they don't really indicate an approach that implies that the government's taking a really strong lead on transition efforts. And some scholars even say that the shape of these plans and the fact that they include kind of global financial institutions actually sort of entrenches business as usual, since they're some of the kind of primary agents steering things. This last point is a particular hobby horse of mine, and it can get a bit technical, but it's one of those ways in which apparently kind of value neutral numbers can actually incorporate kind of really questionable assumptions and have kind of really big effects. So we're referring to here cost benefit analysis in general. When governments assess any investment, they say, right, are the benefits going to exceed the costs, and over what time frame? Which, you know, that makes apparent sense. But you tend to explain simply, you'd sort of, if you're looking out into the future, they try and count in, well, a future benefit isn't as good as a benefit now. Okay. So in that, they use what's called cost discounting. So particularly for investments that are far off in the future, if you apply kind of certain numbers, you'll get very diminished costs on the reasoning that, well, we're better off having that money now, our richer selves, you know, can sort of deal with that issue. And when you get to something like climate, that could be kind of both very troubling in terms of like what you're thinking ethically, how you value future generations, or even is that going to be, have you chosen the appropriate number? And is that going to get in the way of big investments? But we can return to that point if you're interested. So towards a solution, again, this, I suppose my point regarding sort of post-growth or green growth perspectives is, in general, the kind of immediate program for either perspective looks similar enough. I think there's kind of a consensus on this. You have scholars like Mariana Mazzucato. She points to, given the scale of this, you need something like a moonshot. Would be her kind of outlook on this. She calls it mission-oriented innovation policy. So that's the state really kind of pushing the kind of shift of the economy in a certain direction. Green public investment banks and the government really stepping in, as it did, you know, kind of during COVID in the pursuit of the vaccine, to really like step up and encourage research and development into new technologies that we need. You might have kind of explored this a little bit, but given the kind of transitions required, that kind of social dislocation, even actually from, you know, a direct climate perspective, increased systems of social provisioning can actually reduce and aid kind of emissions gains relative to, you know, kind of to concretely illustrate this. An expanded public transport service has a much lower sort of emissions and material profile than a fleet of private cars, for example. So collective provisioning can really aid both in sort of ecological terms and do so without sort of depriving people of the useful things they need. And while kind of current policies are quite controversial because they tend to be regressive in their impacts, you could, if sort of appropriately coupled with other things, you could mitigate against those impacts and encourage, uptake in something like public transport. And to touch on a point without getting too much into it, there's even the idea that, kind of localizing supply chains and using the power that the state has to sort of encourage activity to happen here rather than, far away, can be both pro-climate and pro-regional development. So we can leave it there. I've finished it in 35 minutes, so consider that a success. And I'm happy to answer any questions you have.
Thank you, everyone here, and thank you to Paul. And go have a nice sunny evening if you're somewhere that has blue skies like I have now, or if it's not sunny, go get yourself a lovely warm drink and have a lovely cozy evening. Thank you. Goodbye.
Thanks, everyone.